Now, on a question related to the potential and kinetic energies of a mass oscillating on a spring, had somebody give me a straight line graph. Okay? Now, we know in many ways that the potential energy of a spring is 1/2 kx squared, and that's certainly not linear, and a straight line graph through the origin would be linear. Now, I expect somebody simply got that mixed up with the force equals negative kx, the force, and there is such a graph that's related to a spring. But you want to be careful, and that's really not a mistake you want to make, because if you really believe the linearity of that graph, it's going to mislead you all over the place. And then we had a graph of kinetic energy, which was going down as a straight line. Now, if the potential energy goes up as a straight line, then certainly kinetic energy is going to go down as a straight line. So that's not necessarily an indication of total lack of understanding. It may be just a little bit of carelessness on the nonlinearity of this graph and the nature of a x squared graph, of a multiple of x squared. Okay, so the kinetic energy would look like this, because of course you would be subtracting the potential energy from the maximum potential energy to get the kinetic energy. On an ideal spring, of course, the oscillation is assumed to proceed with no loss of total energy, so that the maximum potential energy is the total energy. And of course, then, so is the maximum kinetic energy, because you have potential energy at maximum displacement, converting to kinetic energy at equilibrium, and then converting back to potential energy at maximum displacement on the other side, back and forth. So it just worried me a little bit to see that straight line graph. And then I think later in the same problem, there's a question of excuse me. Okay, there's no more with this situation. I just remembered what this was as I was coughing a little bit off camera. And this is a different problem, so we'll take this up in the next video.